Hi, welcome to 2.5, where we're going to talk about variation. Specifically, we're going to talk about direct and inverse variation and what the difference is. So when we have mathematical models that are developed for real-world problems, a lot of times the relationships between the quantities involved are expressed in terms of proportionality. So you might remember from physics that force is proportional to acceleration. If you're thinking of the formula, force equals mass times acceleration, so that is linear. When ideal gas is held at a constant temperature, pressure and volume are inversely proportional, and revenue is directly proportional to the amount of sales. So let's talk about direct variation first. So we've got two quantities, x and y. Y varies directly with x, or you could also say y is directly proportional to x if y equals k times x. So y equals kx should look pretty similar to you. It's a linear equation, and k is known as your constant of proportionality, but really all it is it's just the slope. So when you have two quantities that vary directly, as x increases, y is going to increase at a constant rate. Or as x increases, y will decrease at a constant rate. So in this example, you can always pause the video, take a few seconds to read it, and then we'll work it out together. If the monthly payment P on a mortgage varies directly with the amount borrowed B, if the monthly payment on a 30-year mortgage is $6.65 for every $1,000 borrowed, find a formula that relates the monthly payment P to the amount borrowed B for a mortgage with these terms. Then find the monthly payment P when the amount borrowed B is $120,000. Write your answer in a complete sentence. So it's important to understand what we're finding. So the first thing I'm going to do is I'm going to write an equation that relates the payment and the amount borrowed. So in this first sentence here, it says the monthly payment P varies directly with the amount borrowed B. So if I go back and look at my formula and relate y varies directly with x, I can easily make an equation that relates P and B. So here P varies directly with B. So I'm just going to have P equals K times B instead of Y equals K times X. And I'm going to fill in some numbers, and I need to find K, my constant of proportionality, or my slope. So here I know that P is $6.65, and that's equal to K times the amount borrowed, which is 1,000. So I first need to solve for K, so I'm going to divide by 1,000. So K equals, if I move the decimal back 3 places, okay, that's my K. So that's my slope, and that represents the increase, the change in the increase over the change in the run. So now I'm going to take that and plug it into my formula. P equals K, which is now, I know, it's 0.00665 B. So now I need to find the monthly payment when the amount borrowed is $120,000. So they're telling me that B is $120,000. So I'm just going to plug in $120,000 and solve for P. And when you do that, you end up with $798. So what does that exactly mean in words? It means that if the amount borrowed is $120,000, you'll be paying $798 per month. Let's practice another problem. So write a formula for the problem below and find the solution. Here's my key phrase. It says y varies directly with x. So that tells me that y equals k times x. Y equals 5 and x equals 15. So find x if y equals 20. So first we're going to take this first part and plug it in. So they told me y is 5 and x is 15. So I got to solve for k first. So 5/15 reduces to 1/3. So I know that's k, and I'm going to plug that now into my formula. So now it says find x if y equals 20. So I'm going to substitute 20 for y and solve for x. So to solve for x, I could just multiply both sides by 3. 3 times 20 is 60, so x equals 60. The last type of variation we're going to talk about is inverse variation. So when two quantities vary inversely, as one is increasing, the other is decreasing. And if you were to graph two equation or a relationship that's inversely proportional, it would look something like this. So we refer to these as hyperbolas. The equation is different. It's y equals k divided by x. So again, once we find k, we can then substitute values and solve for what we're looking for. So feel free to pause the video and read the next problem, and then we'll work this out together. The maximum weight W that can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length L. Experts indicate that the maximum weight that a 10-foot long 2x4 piece of pine can support is 500 pounds. Write a general formula relating the maximum weight W in pounds to length L in feet. And then find the maximum weight W that can be safely supported by a length of 25 feet. So the first thing we're going to do is write our equation. So they tell us that the maximum weight can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length L. So the equation would just be W equals K divided by L. And then they give me some clues. They tell me that the maximum weight that a 10-foot long piece of pine can support is 500 pounds. So my weight is 500 and the length is 10. So if I solve this for k, I'm going to multiply both sides by 10. So I know that k is 5,000. So I'm going to use that to write my equation, which would be W equals 5,000 divided by L. So in other words, if I want to figure out the maximum weight, I would take 5,000 and divide it by the length of that pine. So here they tell me that you've got a 10-foot long, they tell us that the length is 25 feet. So we want to know what's the maximum weight that can be safely supported. So I'm looking for W, and I'm just going to divide 5,000 by 25. So now 5,000 divided by 25 gives me 200. So, in words, the maximum weight that a 25-foot long 2x4 piece of pine can support is 200 pounds. Okay, that ends our discussion on direct and inverse variation. Please make sure you're doing the homework, make sure you're practicing, and if you have any questions, please reach out to me. Enjoy the rest of your day, everyone.